Okay, so the first type of factoring that we talked about was the greatest common factor. Okay, so if we're looking at number 1, we are looking for the thing that both of these have in common. So if you look at KR and KP, I notice that both of these have a K. That's going to be my greatest common factor. So I'm going to write K here. Then I'm going to write what's left over once I take K out in the parentheses. So when I take K out, I'm left with R plus P. Okay, so let's try one that has numbers and letters. So if I'm looking at number 2, our numbers are 10 and 25. If I think of the factors of 10 and I think of the factors of 25, I know that the biggest that divide both is 5. So I'm going to pull 5 out. Then I want to look at my letters. I have an AC and a C here. Both of them have the C, so I'm going to pull a C out. What you do with the numbers is you divide the numbers. So if I did 10 divided by 5, that's going to give me 2. I didn't do anything with the A, so I bring that down, and it'd be plus 25 divided by 5 is 5, and then I took this C out. So I'd be left with 5C parentheses 2A plus 5. Okay? Now, in number 4, if we look at each one of these numbers, I know that 9 is divisible by 3, 12 is divisible by 3, and 15 is divisible by 3. That's the largest number that goes in each one of them. So we would divide each by 3. And then it's been a while since we talked about exponents. Your GCF for exponents is always the smallest. So if I look at number 4, I have C to the 3rd, C to the 9th, C to the 4th. C to the 3rd is my smallest, so that would be my GCF. So I'm going to put C to the 3rd beside 3. Now, everything that's left over once I pull these out is what goes in the parentheses. So I would divide 9 by 3, which would give me 3. I took C to the 3rd out, so this goes away. Then I would subtract 12 divided by 3 is 4. I had C to the 9th. I took C to the 3rd away, so that would give me C to the 6th. And then plus 15 divided by 3 is 5. I take C to the 3rd away from C to the 4th, and that leaves me just with C to the 1st. But we don't necessarily have to write C to the 1st. Okay, so the next type of factoring I want to talk about is the grouping method. So we always use the grouping method when we have 4 terms. So that's a good way to remember that, is if there's 4 terms. So here, if we're looking at 17, the first step to grouping is to put in parentheses your first 2 terms and your last 2 terms. From there, we're going to find the GCF. So the GCF in 12A plus 3B, I know 3 divides both 12 and 3, and then one has an A, one has a B, so they don't have any letters in common, so it would only be 3. I'd divide 12 by 3, and that would give me 4A plus 3 divided by 3 is 1, and then I'd bring down my B. So you can write 1B or you can just write B. Then I bring down my plus sign. If I think about the factors of 28 and 7, I know that 7 can go into 28, so 7 would be my biggest or my greatest common factor. Then I have an AC in this one and a BC in this one. So the letter they have in common is C, so I'm going to pull C out. That leaves me with 28 divided by 7 is 4. I didn't do anything with the A, so I bring that down. 7 divided by 7 is 1. And then I didn't do anything with the B, so I bring that down. Now, if you look, what you're looking for in grouping is that the parentheses look the same. So 4a plus b and 4a plus b. Those are the same, so that means we factored it correctly. We're going to write everything outside of the parentheses in 1. So 3 plus 7c goes in my first parentheses. And then 4a plus b goes in my second parentheses. And so once you get it in that form with the 2 parentheses, that means you're done. Okay, let's try another one of those. So let's look at number 9. In number 9, the very first thing that I want to do is I want to group my first 2 in parentheses and my last 2 in parentheses. If I think about the factors of 3 and 4, the biggest factor of 3 and 4 that they have in common is 1. So I don't necessarily have to write 1 on the outside. But if I look at the letters, I have an A and B in this one and an A and C in this one. So they both have A in common, so I'm going to pull A out, which would leave me with 3B minus 4C. Then if I'm looking at my second one, again I have 3 and 4, so my greatest common factor is 1. B and C are different, so the only factor I have is 1, which means I do have to write it outside. Then I would rewrite 3b minus 4c, because if you pull out a 1, it never changes. My parentheses match, so that means we're going to write everything on the outside, a plus 1 in parentheses, and then we just bring down 3b minus 4c. Okay, let's try number 10. So in number 10, again, we're still grouping because there's 1, 2, 3, 4 terms. We would put our first 2 terms in 1 parentheses and our last 2 terms in 1 parentheses. Here, I want to make sure that I keep this minus sign with 21. We always want a plus sign between our parentheses. So when you group, keep the minus sign, put the plus in between. Now, if I'm thinking about the factors of 28 and 16, my greatest common factor is going to be 4. And so then if I'm looking at my variable, well, you know that the GCF is always the smallest exponent. So if I had to choose between m to the third and m to the second, I know n to the second is smallest. So that's going to be my GCF. 28 divided by 4 gives me 7. I took m to the second away from m to the third, so that just leaves me with m. Then it would be plus 16 divided by 4 is 4. I took the m squared out, so that goes away. Then, if I'm looking at negative 21m and negative 12, they are both negative, so I want to bring this negative out. And then 3 divides 21, 3 also divides 12, so I can bring 3 out. That leaves me with negative 21 divided by negative 3 is a positive 7m. And then negative 12 divided by negative 3 gives me a positive 4. Now if I look, these match, so I'm going to write everything outside of the parentheses together. So 4m squared minus 3 goes in 1 parentheses. And then our matching we bring down and write in 1 set of parentheses. And so that would be our answer. So the last factoring type that we learned about is the trinomial method. And we use that when we're given 3 terms that don't have a GCF. So if you're looking at 13, 2, 7, and 6 don't have a GCF other than 1, and not all of them have x's, so that means we're going to have to do trinomial method. Now, the steps to trinomial method. The very first thing I'm going to do here is multiply my first number times my last number. That's going to give me 2 times 6 is 12. Then I'm looking for something that multiplies to give me 12, but adds to give me a positive 7. And so that 7 comes from that middle term right there. So if I think of the factors of 12, I know that's 1 and 12, 2 and 6, 3 and 4. So I know 1 plus 12 can't give me 7. I know 2 plus 6 can't give me 7, but 3 plus 4 would give me 7. So this is going to be what I call our magic numbers. Now, the next step, we bring down our first term, 2x squared, and we bring down our last term, which is plus 6. Then we take 3 times 3 and 4, and we replace 7x with it. So plus 3x plus 4x. And the reason that works here is because if we added 3x plus 4x, that would give us 7x. So it's basically the same thing. We just broke it apart. Now, we have 1, 2, 3, 4 terms. And so we know when we have 4 terms, we group. So we're going to take our first 2, group them together, our last 2, and group them together. If I'm looking at 2x squared plus 3x, 2 and 3 don't have a GCF other than 1, but I notice they both have x's. So I'm going to pull out an x, and that would leave me with 2x plus 3. Then, if I'm looking for the GCF in 4x plus 6, I know that 2 divides 4, and it also divides 6, so I'd pull out 2. If I did that, 4 divided by 2 gives me 2x, and 6 divided by 2 gives me 3. Now, if I'm looking at my parentheses, these match. I have 2x plus 3 in both, so that means everything outside of the parentheses we write in 1, so x plus 2, and then we bring down our matching parentheses, 2x plus 3. All right, let's try another one of those. So again, our first step in trinomial method, first we want to see, does this have a GCF? So 1, 7, and 10 don't have a GCF other than 1, and not all of them have C's. So you can't factor those by GCF, but we'd have to do trinomial method. So we're going to multiply the first times the last. Now there's not actually a number in front of C squared, but it's understood to be a 1. So we do 1 times 10, which gives me 10, and then I'm looking for something that adds to give me this middle number. So adds to give me 7. So I know factors of 10 are 10 times 1 and 5 times 2. 10 plus 1 can't give me 7, but 5 plus 2 can. So that's going to be my magic numbers, 5 and 2. So we bring down our first and our last, so c squared and then plus 10. Now my 5 and 2 are going to go in place of my 7c. So when I put them back in, I want to make sure that I add my variable to it, so I'd get 5c plus 2c. Now I have 1, 2, 3, 4 terms. So what we're going to do is we're going to group our first 2 and group our last 2. If we're looking for the GCF in our first parentheses, the number GCF is 1, and then you notice they both have C's. The smallest is just C, so that's what we would pull out. That would leave us with C plus 5. And then looking in the second set of parentheses, we have 2C plus 10. I know 2 can divide both of those, so that's going to be my largest number that divides both, or my GCF. We divide by 2, and that gives me C plus 5. Now, I'm looking, these match. That means I did it right. So everything outside the C plus 2, we write in one parentheses, and then the one that matches, we write in the other. So that would be our final answer. Okay, I want to try one more of these just to make sure we got it. So let's look at number 17. So in 17, again, our steps are still exactly the same. We're multiplying our first times our last. So 3 times 6 would give me 18. Then I'm looking for something that adds to give me this middle number right here, negative 11. I told you earlier when I was teaching you about trinomial method that if it starts positive and then ends negative, if this is negative and it ends up being positive when you multiply, that means the two things that you multiply are going to be negative. So I'm going to find all the factors of 18, and then once I find 2 that will add to give me 11, I'm just going to make those negative. So I know the factors of 18 are 1 and 18, 2 and 9, 6 and 3. So I know 1 plus 18 can't give me 11. 2 plus 9 gives me a positive 11. So that means it'd have to be a negative 2 and a negative 9 would be my magic numbers. And what you can do to see if that works is just plug in negative 2 plus negative 9 in your calculator, and when you do, you'll realize it gives you a negative 11. So that's a way to check. Now, we're going to bring down our first term, which is 3n squared. We're going to bring down our last term, which is plus 6. And then we're going to take our magic numbers, negative 2 and negative 9, and plug it in for negative 11. So this would be a negative 2n minus 9n. It doesn't matter if you write 2n first or 9n first. You'll still end up with the same answer. So now we group our first 2 and group our last 2. If I'm looking for my GCF here, I know 3 and 2, the only GCF I'm given there is a positive 1. I don't have to pull that out, but they both have n's in them. So I'm going to bring out an n, which would give me 3n minus 2. Now, in my second set of parentheses, I have a negative 9n plus 6. So if you notice here, I have a positive n, negative number. Here I have a negative n, positive number. So when I pull out my GCF here so that the signs will match, I'm going to need to pull out a negative so that it changed both of these signs. So I want to pull out a negative here. I know 9 and 6 have a common factor of 3. And so if I divide this by a negative 3, a negative divided by a negative is a positive. That gives me 3n. And then I divide this by a negative 3. A positive divided by a negative gives me a negative, so that would be a negative 2. Now, these match and these match. So I'm going to rewrite my answer. Everything outside, the n minus 3. And then everything that matches, 3n minus 2. And that would be my final answer.